What is the Earth, guys? Good question. Let's go through a couple maps. First map I'm going to introduce today. I don't know how I can work. I'll never say it. First map I'm going to be introducing today is the Mercator projection. Mercator projection, introduced by Gerardus Mercator in 1569, widely used for centuries, including today, in various forms by Google Maps and many other land services. The only problem with this map that we use is that it drastically distorts size and shapes of continents. For instance, Alaska is nearly as large as the USA. Greenland is roughly the same size as Africa. Europe is only a bit larger than South America. When in reality, I'll show you another. This is the Gall-Peters projection. In reality, Alaska can fit inside the USA about 3 times. Greenland can fit inside Africa an incredible 14 times. South America really doubles Europe's landmass. That's what introduces me to my next map, the Gall-Peters projection map. Presented in 1974 by Dr. Arnold Peters, who claimed he invented it, though well after the discovery of an identical map made by James Gall in the 1800s, therefore calling it the Gall-Peters projection. That's the difference between the two. Now, guess which map that our leading space organizations tend to use? This is the Google's map showing that. This is NASA from the Earth. All these pictures that I gathered are all from NASA.gov. Any one of us can go and choose to look on NASA.gov. Any one of us. This is not like something I had a special organization to get into. These are all on NASA.gov. Guess what map they used to use? They actually can't even make up their mind. That one tends to be the, what is it? The Gall-Peters projection. That one is the Mercator projection. The map I'm going to be introducing today, oh, besides this one, my bad, I forgot to introduce this one. This one shows, these are real pictures from NASA.gov. This is one from 2012. You see the size comparison of America. See how it grows, like 4 times the size? The next year they shrink it up. The next map I'm going to be introducing today is Alex Peterson's 1892 map, which I believe to be the most accurate map of the Earth today. Well, I'm going to have to explain a lot, it sounds like. Because, well, we know the Earth would be 93 million miles away. This amount in some circumference, actually I think that's wide, and then 4.3 million miles in circumference. But have you guys ever heard of the torus effect? Nobody ever heard of the torus effect in here? No. It's, I'll explain the directional pattern right now. It'll make it easier for you guys to understand this map. In this map, it's going to be a stationary plane. When the Earth is stationary, the sun, moon, and stars all wrap around us. Well, a lot of people don't get about this is the directional pattern. That's what I'm willing to explain right now. On the directional pattern of this map, let me go back, is a giant torus effect, which I wrote right here. This way is always going to be west, coming out of California. This way is always going to be east, coming out from New York. This way is always going to be south. And this way is always going to be north. So the north is always going to be right there, and south is always going to be there, right? The torus effect. It's kind of easy to explain seasons and directional patterns and all that. And if you guys haven't looked into the torus effect before, I would. Because it explains a lot about the Earth. There's another effect of the torus effect. The torus effect, in my opinion, is a perfect example of the law of attraction. Another thing I've been looking into quite extensively. You give out good energy, you get good energy. Yin yang, doing to others as you would have do them to you. Karma, whatever way you want to look at it. You give bad energy, you get bad energy. You give good energy, you get good energy. The reason I'm going to explain my Earth being a stationary plane, people ask, oh, don't you fall off? Where's the end of it, right? Directional pattern, torus effect. I had some stuff written down, but I'm just going to go off my heart. So, on a globular model of the Earth, every time you head south, which way are you going to go? You're going to head toward Antarctica every single time, right? Same like this. Every time you head south, you're going to hit an ice barrier every single time. There's Antarctica. By the way, there is an Antarctica treaty stating that we cannot go there anymore. It was signed it was officially organized and officially illustrated in 1956 and then officially signed and originated in 1961. Don't quote me on that, but you can do your own research on it. That's the reason we can't go to Antarctica. Because there's an Antarctica treaty stating that we can no longer explore there. And if that interests you a little bit, I would look into Admiral Richard E. Byrd, who was a polar explorer who spent most of his life exploring Antarctica. He came back with so much information about minerals and resources that we could use. But right after that, they cut it off and said, we can't go there anymore. Interesting fact. This is the torus effect of being the Earth. I'll get back to more of this later. Next thing I want to introduce about this map being the most accurate map in the fucking Earth is that it's stationary and that the sun and the moon have to wrap around us correctly. I have a lot of proof of that. I have a cell phone. Do you guys have a cell phone with a light on it? These are the sun's rays. The sun simply is going to run around us, making a wrap around the Earth in a torus effect. Okay? Another proof I have of that is the sun's rays. If the sun was 93 million miles away, let's make a little size comparison of it. If this is the sun and this equals to the entire structure of this building, let's pretend that's the sun. And the Earth is 93 million miles away, probably about this size. You could put this dot in the next town away, right? So if we had sun rays coming in from 93 million miles away, we have sun rays coming from the sun. Da-da. If we had sun rays coming from 93 million miles away, they would always consistently come in parallel. But they do not. On every single time. You see the triangular angle, the sun's rays come out every single time. This is a consistent basis that happens every time. And there may be some phenomenon with weather making it come in at triangular angles at all times, but it doesn't add up on a consistent basis. This picture right here kind of gives it all away. Look at these hot spots the sun rays are giving in a triangular angle. There's some people that take the geometry equation and proven the base and the angles and the actual height of the sun. The actual height of the sun, I've never done it, I've never done the equation, so I can't get too much into it, but they predict to be just thousands of miles high. Another proof I have of that, don't mind me getting over here. This is a video that was released. How do I play this?
I usually just copy the URL into, I'm not sure it's using NEDIR.
Yeah, it's YouTube. We can skip this one. I'm not that worried about it. It's It's a water balloon, went up to many elevations and showed a hot spot on the clouds, proving the the sun is not 93 million miles away. You can't have a hot spot on the clouds, and anybody can go look up that video I was just about to pull up. It's blown up so drastically. You can look up anything from hot air balloon, look at the sun, hot air balloon, hot spot, anything. It's obnoxiously blown up on the internet. The next thing I would like to introduce is star trajectory. This is my favorite. This one is by far my favorite. Because if you, excuse me, if you focus your camera on the Polaris star, which is known as the North Star, known as the brightest star in the minor, the minor something constellation, known as the brightest star, also known as the non-movable star. If you take your camera, you put it up to the North Star, and you do a time lapse, which on this map, we put the North Star right here, right? Thanks to any compass on this map is going to head you west, any compass on this map is going to head you east, any compass on this map is going to head you south. Any compass on this map is going to head you north. Correct, guys? So the North Star, in any direction on the planet, is going to put it right here. So if you focus your camera on the North Star, being Polaris, you'll get a star trajectory, what girls like to call star trails, like this every single time. Indefinite proof that all the stars wrap around us. Every time, guys, no matter what part of the earth you're at. Another thing I'd like to mention is the measurements of flatness all around the world. We have Lake Erie, Australia, 3,668 miles squared. We have Wadi Rum, Jordan, 278 miles squared. Remember, guys, we're supposed to have an 1/8 inch of curvature every mile squared, according to our circumference of the earth, right? Doesn't happen, has never been accurately measured once in human history. Bolivia Salt Flats, Utah. No, that's Bonneville, Salt Flats, Utah. That's only 40 miles squared. Had to throw some sex to get you guys interested, so. Kansas State, it's known as flat as a pancake. This is the elevation level of a pancake and the elevation level of the state of Kansas. Interesting. Remember, 8-inch curvature every mile squared. Interesting. That's Kansas being as flat as a pancake. Curry, Australia, 764 miles of straight flatness. We also have Lake Baikal, Siberia, an amazing 12,248 miles squared. That's honestly why I got so excited about New Mexico having salt flats, because I'm going to be the first one to measure that. These are all accurate measurements of flatness. This place is so beautiful, I had to show a few extra pictures. Look at that though, beautiful. Grand Canyon, at one point it's measured 277 miles long, 18 miles wide. Another measurement is 1,900 miles squared, flat, straight across. San Francisco Bay, 1,600 miles squared. Western Australia, Highway 1, 90 miles squared. Zero curvature. Bolivia Salt Flats, this is one of my favorite ones. This is the only one I thought existed until I looked more into it. Bolivia Salt Flats, 4,000 square miles flat. Where is the curvature? Danakil Deserts, the Everglades, Florida. All over the world. Next thing I wanted to get into, the law of perspective, how objects fall out of the sight of your vision. This is two of the main points that Aristotle thought the world was a globe. He didn't understand the law of perspective at all. The law of perspective is simply how something falls out of your vision. So what he thought, whenever he was heading north, the south stars were slowly curving out. And he had to assume that the world was round because of that, right guys? Wrong. He also thought that whenever he was seeing a boat going out of the ocean and went so far it fell out of the curvature, he did not understand the law of perspective, and this is proven day in and day out with boats and people on the ocean, and they will take cameras with high power zoom, saying it fell out of the curvature, and simply zoom into the boat. It's easily proven, every single time. Next thing I'm going to get into is the Coriolis effect. Don't think I wasn't going there, right? This is the Coriolis effect on the globular Earth, right? Hurricanes spin this way on this southern hemisphere, right? On the northern hemisphere, they spin this way, correct? So if you take Earth as an actual torus effect, which it is, that's the torus effect. That's the torus effect looked at another angle. If you can imagine this, we're going to explain to you guys the torus effect. So if the torus effect with all, okay, this I need to rewind. I'm going to go ahead and take this half of the circle, okay, and then I'm going to compare it to this half of the circle, okay. So with this part being the northern hemisphere, correct, and this part being the southern hemisphere, correct, according to the heliocentric model of the Earth. The Coriolis effect is simply going to be, it's like on this top of the plane, hurricanes are going to spin this way. On this part, hurricanes are going to spin this way. Another easy analogy to explain is take a quarter, roll it off that way, it's going to roll this way. Take a quarter, roll it off that way, it's going to roll that way. Do you guys understand that? Coriolis effect explained on a flat plane Earth. You're welcome. Next thing I have to introduce is, what about satellite imagery, guys? There's so much satellite imagery showing the curvature of the Earth. There's so much saying it though, right? One problem I have about satellites, and anybody is welcome to look into this. Anybody. Satellites hang out in the thermosphere. The thermosphere is chilling at temperatures of 931 degrees Fahrenheit to 3,632 degrees Fahrenheit, an average temperature of 2,282 degrees Fahrenheit. Satellites are made of titanium, nickel, cadmium, aluminum, and beryllium. The only problem I have about this is the melting points of these metals is titanium melts at 3,000 degrees, nickel melts at 2,600 degrees, cadmium melts at 600 degrees, aluminum melts at 2,100 degrees, beryllium melts at 2,348 degrees. But the temperature of the thermosphere that they chill at, 3,632 degrees. These metals do not even compare to be in the thermosphere. Their numbers don't make sense. Their numbers don't add up. So either they're lying about satellites or they're lying about the temperature of the thermosphere. Either way, they're not accurate with their numbers. And that's a big deal to me. I do not believe in the government or anything they say in any way, shape, or form. I'm a truth seeker. Next thing I want to introduce today is the astrolabe. The astrolabe I don't really want to get into too much because it'll take all class. The early astrolabe was invented in 220 BC. Greek for a star taker, it's a clock, it's a navigational device, it's a calculator capable of working out several different equations. But the main part I want to base about this is that bases its positioning off the North Star still works with precision to this day. Just another indefinite proof that we are a stationary plane. Have you guys ever heard of Auguste Piccard? This is honestly a funny statistic to me. Has anybody heard of Auguste Piccard in here? You have? Good, awesome. Auguste Piccard was a big deal back in the 1930s. I was so inspired by him, I dressed up as him for Halloween. He shattered altitudes of elevation and shattered altitudes of depths of the sea. Do you know how high he got in his granola device? Thousands of miles high. Thousands. Do you know what his view of the Earth was? In a 1931 Popular Science magazine, August issue, do you know what he says, word by word? Talking about the Earth here. Before NASA, by the way, before NASA. He explains the Earth to be, talking about the Earth here, it seemed, where's that? It seemed a flat disk with upturned edge. Interesting, we never heard about this guy, right? He shattered altitudes. He was a scientist, explorer, everything. I'm going to wrap this up real easy. Sorry to take up so much of your time. Gravity is density, not the theory of relativity. And I'm going to have to work on my paper for this one. Gravity, as we know it, the theory of relativity, right? Gravity is a force that cannot be seen, tasted, heard, felt. We don't know the mysterious force of gravity. The fact that it was even given a name kind of offends me. But what we do know about gravity is that it has a lot to do with density. It's a perfect scale to prove it. Density is the reason a helium balloon will rise in the air, because the helium is less dense than air. Therefore, the balloon rises. Same with a hot air balloon. Hot air is less dense. Therefore, the air in the hot air balloon, it gets hot and it expands, which makes it less dense. The theory of relativity, you can throw out the window. I'm going to give you a reason why. If the theory of relativity was accurate, you would be able to take a beach ball, put it on the bottom of the ocean, and it would stay there due to density and pressure of the theory of relativity bringing everything towards the Earth. But that is not accurate. The beach ball rises due to the air inside of the beach ball is less dense. Which brings me to my next one. Water convexity. Water convexity.
Just because I think there are other classes waiting.
No, that's fine. I'm going to wrap this up real quick. Anyone that wants to say they can. Water convexity. Water never convexes. All of this is I'm finishing. Water never convexes ever. That's an H2O fact. So, if we can take a ball and drop it inside of a cup, is the ball going to submerge the water, or is it going to convex out of the water? It's going to submerge, and water is going to stay flat because H2O is known to stay level. That's an H2O property. Right, guys? So, you take a brick and drop it all into that. So how are you going to explain water convexity around a spinning ball that submerges around a spinning ball when the water is made out of 71% water, when H2O is known to stay flat? Can anybody give me an answer for that? Anyone? Water convexity? No? I have your guys' best answer. Atmospheric pressure. We all know the world to be a positive pressure system, right? We all know space to be a negative pressure system, right? To have a negative pressure system against a positive pressure system, it would cause an equilibrium. We all know that. A balanced force. So there's no way we have a negative pressure system and a positive pressure system that doesn't have a solid barrier. We need a solid barrier. Without it, it causes an equilibrium. So with everything we've been talking about space and Earth, I don't know if I believe it. Science says no. Do you guys know what I mean? And I can go ahead and wrap up my conclusion, but I don't want to take up too much of your guys' time. If you guys really want to hear my conclusion, I'll tell you why. If not, you can ask me outside of class.
Go ahead, you heard me.
Go ahead. You guys want to hear it? Perfect. Thank you.
If you can do it quickly, because
Yeah,
you're
okay.
class.
She's got
Now, I could have gone on for hours presenting you guys information about this topic, but it's really something that needs research. And the fact that you guys have been taught something else your whole life makes it that much harder to even adopt the thought to think it's possible. What the crazy part is, with all the technology we have and access we have to information that we have, we still depend on government organizations for the observations of this Earth. Every observation and experiment ever done all proves we're stationary and not in motion. All the way back from George Airy's failure in 1857 trying to prove that we were in motion, but proved we were stationary. Even Albert Einstein said, "I have come to believe that the motion of this Earth cannot be detected by any optical experiment." Another crazy fact about the heliocentric model of the Earth is that we accept today. The theory went from Pythagoras to Nicholas Copernicus to Galileo to Johann Kepler to Isaac Newton. Do you know what all these individuals have in common? They're all Freemasons. Freemasons have ran our world since the beginning of this country. And if you don't know about Freemasonry, we have 30 of the 56 signers of the Declaration of Independence being practiced Freemasons. There was 8 official members. There's 14 official Freemason members of the United States. So like we're just like, oh, everybody with the heliocentric model of the Earth, we're just going to run with it and take it. Freemasons run the world anyway, right? We're going to believe anything they say. But when you actually go out and do your own observations of the Earth, it proves wrong every single time. And I could go on to satellites being fake. I already did that. Big story, long story short is, why? 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 You know what I mean? I have this all written down, but I'm just going to go from the heart. You know what I mean? A spinning ball going through the galaxy, 1,000 miles per hour, doing a 360 rotation daily, going around the sun at 66,600 miles per hour, and the sun is going through the galaxy at 480-200 miles per hour. And then the next celestial star is 93 million miles away, and then the next celestial star from that is trillions of miles away, and then there's trillions of celestial stars in the sky, right? Your place of importance becomes less than a grain of sand when it comes to the comparison of the universe. But all of a sudden, if we're a stationary plane, and the sun, moon, and stars all wrap around us, which can be proven through star trajectory, it all of a sudden makes you a lot more important. It all of a sudden puts everything around you. It proves precision. It proves made with precision. It proves creator.
Okay, we gotta wrap it up because they need to get in.
Thank you.
All right.
Preste atenção. Preste atenção. Preste atenção. Que os polícia vem aí. Preste atenção. Senão um barraco vai cair. Preste atenção. Ou então daqui PT dali. Preste atenção. Cerrado é fogo no verdinho. Preste atenção. Que os polícia vem aí. Preste atenção. Senão um barraco vai cair. Preste atenção. Ou então daqui PT dali. Preste atenção. Cerrado é fogo no verdinho. Preste atenção.